Welcome back to The Roll Up. Today we had a great conversation with one of our good friends, Dino from Fluent. We talked about their recently announced blended execution design. We talked about why this is a very important design transition for the VM environment from a single execution environment moving towards a multi-threaded execution environment. We talked about why Fluent made this choice and what Dino sees as the progression of modular execution layers. Dino's been pioneering the modular push since the earliest of days, so we really value his opinions and we enjoyed learning and understanding from him at a high level what this means and what you can expect from Fluent and the execution layer going forward. We hope you guys enjoy this video. Let's jump right in after a word from our lovely sponsors.
Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today.
Welcome back to The Roll Up. Today we have Dino from Fluent, of course, here with Rob. We're talking more along the lines of this broader modular thesis, what I kind of consider now to be these subcategories of the modular thesis kind of emerging and different teams working on specific parts of the stack and kind of perfecting their design. So today we're going to talk about Fluent's blended execution model and kind of what this entails and how they are going to bring this to the market and kind of how it works. Of course, we have Rob, the Hooded Bandit today. GM, sir, welcome on as well.
GM, sir.
The Hooded Bandit. Good to be here, boys. Always fun.
Welcome, Dino. Yeah, I mean, you guys have pushed this blended thing. Like, I'm not even sure what it is yet. Like, we're going to dive in. We're going to get the first glance, first inside look. So, yeah, why don't you tell the people kind of like a little bit about yourself and generally like how you came to this blended realization?
Sure. Yeah, so as you said, I'm Dino, one of the co-founders of Fluent. And yeah, we're building the first blended execution network. And the way to think about blended execution networks are very simple blockchains that natively support apps from different ecosystems. So I'll unpack that in a bit, but that's kind of like the succinct definition of it. It could be useful to just like talk to how we got here. I know I came on the pod maybe like a half year ago, or maybe even more at this point, and the focus was more around, or the discussion was more about around a WebAssembly, and that's um, just to be really like clear about it, like that is still at the core of kind of what we're doing. But instead of being the whole story now, I think it's like part of like a bigger story and like a bigger kind of vision that we grew into. And so would it be helpful I just kind of walked through kind of like how we got from there to here?
Definitely. I have you in my books as a WebAssembly cloud app maxi, so I would love to understand this for sure.
Well, the background part of it, yeah, maybe I could just rehash that for a second to explain the cloud app maxi part. I spent before getting into crypto, I spent quite a number of years in Web 2, just around dev tooling and cloud infrastructure. So always kind of looked at it through that lens about like, building better developer experiences and tools to help them do things they couldn't do easily before, or even just making things kind of like more performant or agile or whatever. I've always just been an infrastructure guy. And so got actually like pretty crypto pilled like right away by like Ethereum and rollups. Like I know that's kind of weird, but like I actually just dove in past like the DeFi degen part, and I've kind of been like backfilling that just because like you clearly need to like know a lot about the market. But that's really how I got into the space. So started doing some work for actually like Polygon, a few other kind of roll up projects, whether like later stage and earlier stage. And then last year, right around this time, started Fluent. So just like quickly explain the cloud part. But yeah, I think since the last time we talked, last time we talked, we had probably just shipped our private DevNet, and that was very Wasm focused. So you hear this like WebAssembly thing, and what WebAssembly reason why WebAssembly is very interesting is because it allows programmers to build with like tools that come from Web 2. So, if you support well, WebAssembly is this runtime, right? And so um, when you support smart contracts in languages that compile down to WebAssembly, that lets, and let's just say Rust or C++ or something like this, it lets developers bring the millions of libraries that are already written in those languages and actually run them on chain in a verifiable way. And that obviously has a lot of repercussions, um, especially like I'll say like an extra degree of composability like within that sandbox, right? Because like you don't have to, there's just that many millions of libraries that like you don't have to write yourself. I mean, this is just like how tech works. Like the advantages of having like more tools in the toolbox just compounds. And so we've always found WebAssembly very interesting, and that is where this project started. So it started off as like a ZK rollup that had a WebAssembly base. And then so we were working on that. We were focused on Rust as a language. And we got the DevNet stood up around the turn of this year. And then what we decided to do is introduce, like, make it EVM compatible. And we had this design kind of set from like before that, but what we started to work on was the actual like interop between the EVM contracts and the Wasm contracts, because in our heads it's just like that would be the most powerful thing. And what we found is like that's actually a really hard problem to solve. And it wasn't super clear at the time, because a lot of people do throw around the, hey, we're like this VM and EVM, we're that VM and EVM. But like when we actually kind of dug into it, we're like, it's not that hard to do like a very okay job with it, but it's like really hard to do like a really good job with it. And so we kind of went honestly back in the lab for like a few months and said, let's actually solve this, like truly solve this, because we haven't found anybody else who did. And then we ended up, 3 or 4 iterations later, honestly, found a pretty elegant design that lets, the EVM apps, the apps that would have been deployed to an EVM environment, get deployed to this Wasm environment. Similarly, the Wasm apps get deployed to the Wasm environment. For those apps to actually be able to like call each other, for the developer experience to be very seamless. For users, the thing is actually EVM compatible in a way that like developers don't have to switch wallets when they're trying to use like, the EVM apps versus Wasm apps. It's all just, you use MetaMask and like, or whatever EVM compatible wallet, and that's it. And that's how I guess then we started realizing that the approach that we built was actually quite scalable, like because we architected it from the ground up that way, which we can get into some of like the elements that like make that possible. But what we realize is, this is actually kind of scalable. Like we can add more VMs like pretty easily. And then we clearly at the same time, like Solana is getting like more and more powerful and popular, and more and more SVM apps are being developed. Like look about it, like what did Phantom just hit, like one of like the top downloaded wallets or actually apps in the App Store. And so clearly their ecosystem has reached like incredible escape velocity. So we said, okay, well, wouldn't it be cool if we could actually kind of build on this idea and make an environment where the EVM, Wasm, and SVM apps can all kind of play together nicely. And happy to, of course, talk through like why that's interesting, but that's kind of how we got here.
That's where I think we're headed. Is how ultimately those all fit together, right? And this is what the blended thesis is made of. This is like where it came from, was the initial design to deploy these EVM apps on a Wasm iteration. And then you realize that is scalable and generalizable to a bunch of other ecosystems that you can deploy apps. And so how did that come about? What kind of gave you that impression that it was scalable, and then now realizing that you can apply this type of design to multiple different ecosystems? What's the power? What's the significance of this new blended architecture?
Yeah, so let me like go a step further and kind of contrast that with how most of the L2s and the execution environments are built today, and then how people have tried to, I'll say, do like more or less workarounds to what we ended up kind of designing from the ground up to be a blended execution environment.
Navigating multiple blockchains can be complex and cumbersome. Let's say you want to deposit into a lending market on Polygon because they have the best rates, but you only have funds on Optimism. So you bridge your funds to Polygon only to realize that you need Matic to pay for gas. Maybe you use a centralized exchange, or you ask a friend to pay for the gas, but only then can you finish your transaction. In a chain abstracted future powered by Connext, this is not the situation. You can connect your wallet to any dApp from any chain with all the complexities of swapping, bridging, and depositing, all completely abstracted behind the scenes. Head over to connext.network, that's connext.network, to learn more about Connext Chain Abstraction Toolkit.
So I would call most of the L2 or the most of the existing execution environments single execution networks, right? So it's like you have this state machine that natively supports apps from one VM, like one state transition function, or more specifically a VM. And that's great. And I would say the vast majority of L2s are built this way, and blockchains are built this way. But what we've seen over the past year has been this like really impressive momentum around the alt VM thesis, right? Like you guys are well aware of it. You see kind of like clips and movement, and a lot of these guys like gaining steam, and people are getting very interested in broadening like the design space of the execution layers. I mean, that's like, we see that as well. I mean, it's once you reach a point where you kind of more or less solve like the hardest of the scaling problems, like where does a developer's attention go? Like, okay, I have enough of it now. Now I want to do more with that block space. And so like over the past year, all these alt VMs popping up, and like all for good reason, right? Like Wasm, as we talked about before, has this like very accessible environment where, people can come with knowledge of languages that are from like Web 2. There's also kind of the fact that even if you are like a Web 3 native, you get more tools in the toolbox. We talked about that. Move is doing some really the movement guys, like especially, but just the Move VM in general with formal verification and parallelization. So there's like, SVM with parallelization and like the ability to write in Rust smart contracts. And then also just that's on the technical side, even just the ecosystem side, as I said, like that's been very, very compelling. And so basically like each of these like alt VMs have compelling attributes. And for the single execution networks, like how things have existed up until today, you basically have to treat like you kind of have to trade them off in like a pretty meaningful way. Like if we wanted to just like go whole hog into Wasm apps only and have a single Wasm execution network, well, we're trading off like all the EVM user base, all the SVM like apps. Like you're kind of just like isolating yourself in a way. And so we just think that it's much more compelling to be able to actually blend these things together. And clearly, so other people have been noticing this recently as well, right? I mean, this is like seems like a very natural evolution. But the way people have tried to solve the problem so far, we found very suboptimal. Where like since if something's not designed from the ground up to be able to like natively support these apps, and again, like we can go a level like deeper at some point and talk more about like how we enable it. But if it's not designed in that kind of way, and you really just have like a single execution network that it natively only supports one, you can kind of retrofit things on there. But it's going to be clunky. Like users have to actually switch wallets to use it. There's different like tokens that you have to use on one, what kind of actually, even though it's like one network, it feels like two networks. Like you have to bridge from one experience to the other. And there's a reason why, some of these solutions like haven't gotten a lot of traction. And I think that once you actually make that experience frictionless, I think you see some very different behavior, and we're certainly, we're seeing a lot of excitement for it. But yeah, it does really have to do with the fact that we still have this Wasm base, and we've kind of like architected the system from the ground up with a couple like very interesting like innovations. There's like compatibility contracts that basically support the kind of interop between the different apps in different languages and across different VMs. And then there's this like special like zk tree that we developed as well that helps make sure things like stay in balance. And so yeah, that's kind of how we see the evolution, I guess, from single execution networks to what are now blended execution networks.
Right. Okay. I think that there's some like, definitely some more in the weeds kind of questions, but I think just kind of like staying out for the most part, trying to think about how this could work like in practice, and maybe thinking about like what the future of execution layers would then look like thinking on this paradigm of blended. Yeah, maybe you could give us some examples of kind of applications which could be blended across various execution environments, and like, how that would look, whether it be apps on different rollups, kind of all, with different implementations, or apps on a single rollups with code bases from different kind of like coding languages or execution environments, or like kind of how that practically would look, and then maybe also can get into some of the future of execution environments as well.
Perfect. Yeah, let me talk to something I meant to mention before, but then I think got sidetracked. Which is like, why should anybody care about this? Like, what are the kind of like benefits? And that clearly ties into, what you could build with it as well. And then I'll talk to how we see like different execution networks, blended execution networks popping up over time. Because one thing that I want to make really clear is like, we don't see this as kind of like we don't look at our environment, even though I'm talking about this like single state machine that can support different apps. We don't look at it as like, we're not trying to eat everybody's lunch. We're not going to support all the VMs. Like, we want other people to blend other things on other networks. So we can get to that. So why should anybody care about this, right? Like, what are the benefits of this thing? We put it into two buckets typically. The first bucket is just diversity of ecosystems. And we did, talk about, or unification of ecosystems rather, where, you can have for example, like 10 best EVM apps and the 10 best SVM apps actually sitting in the same place to share liquidity, share user base, right? Like, all of a sudden you have apps from either of these environments that get to actually just by default, like, dip into kind of the full user base of the other environment. There's kind of like new types of apps that their app has access to now that they would never get on a single execution network of its origin VM kind of thing. So I think we look at it as like an extra execution point, I guess, for each of these ecosystems. And I think there's some pretty cool like emergent things that happen when you put them all in like a single state. And then the other is the diversity of tooling. Like, I think that this is where it ties into your question of like, what can be built with this. And it's some of the more like interesting cases. I'll mention. Are you guys familiar with like the autonomous world kind of like thesis? Like, I'm not saying specific to games, but the idea that you might have one developer who builds the primitives of a certain game, or kind of like the low level primitives of a world, or what doesn't really matter, of a social media application. And then what is the core thing to the like autonomous world like thesis is that you would have other developers like coming in and kind of like composing on top of your thing. This isn't much different than just like the composability you see in DeFi, but usually think about it as like, one distinct app composing with another distinct app. But I think what's very interesting is if you can almost like create apps like across using multiple different languages from potentially multiple different kind of like VM origins. So maybe the core part, maybe you're building a DEX and you're trying to innovate it on using some Rust libraries. And so maybe like you want to use like ERC20 tokens and, copy and paste like a decent amount of like an existing DEX because it's open source and you can, but you do want to innovate. And like, so you pick up something in Rust to innovate like where it makes the most sense. And then I'd call that like a blended app basically. And so when things get that seamless to actually kind of compose, tools together, and you have this like vast, diverse set of tools to actually use in this one place, I think you get pretty awesome experiences that emerge. And the other thing is, I mean, if even let me just like relate that to like the way even like Web 2 works, right? In the past, maybe last time I came on here, we talked about the Wasm example too, where when Wasm gets put in the browser and you get extra flexibility you couldn't get before. And that's how, for example, like I think I probably mentioned Figma. So like Figma comes in and says, okay, the best way to program this application, because we need it to be like very performant and in real time in the browser, is by using both, not just JavaScript, but using both JavaScript and C++. And so you can start to see that same thing, that same kind of like thesis that we have within just a Wasm environment, just expanding across multiple different environments and more languages. And I think it's the same type of idea. You even see this existing in like the ML world today, right? Like what are all these machine learning models? They're kind of like Python wrappers around lower level C++ libraries. So like that's just like how people build today. And we're just trying to like, make that easier to do on an L2. And to answer your second question around how we kind of see the future of execution environments, I mean, yeah, to emphasize, we don't see this as kind of like, a collapse back into like one big fat state machine that like has all the applications and, Fluent wins, sorry, everybody. Like that's not how we see it. We see it as just like a better way to design execution environments. And the same way you might, I mean, if you have a thesis for 1,000 or 1,000,000 rollups, well, we would like to see, we share that vision. We would just like to see it be, 1,000,000 blended execution networks instead of 1,000,000 single execution networks. And each of those can be just like hyper customized for their own needs. And so that's generally how we see it.
Fuel achieves higher throughput by utilizing a novel UTXO-based approach that allows for parallelized execution. This design significantly accelerates transaction processing, which enables Fuel to handle vastly more transactions than non-parallelized systems. Thanks to advancements introduced by Fuel, Ethereum rollups are set to be more powerful than ever before. And Fuel is not just enhancing Ethereum rollups, it's redefining them, making them faster, more scalable, and more adaptable to meet the needs of modern applications and developers. Go to fuel.network, that's fuel.network, to learn how to build on the Rollup OS. There's a lot of chatter around chain abstraction these days. And so what you kind of mentioned with like these wrappers around lower level languages, I'm starting to think of like these chain abstraction protocols as doing similar, and there's a lot of nuance in the chain abstraction world. So I don't want to like say that everyone's kind of just wrapping and trying to compose and orchestrate liquidity across different places. But it seems like what you guys are doing at the execution level is very, very based, very low level, and is going to approach chain abstraction at a much more fundamental, in a much more fundamental way. So I'm curious, like, how would you say this impacts the end user? Does it mean we're switching chains less, like chain abstraction would have you think? Does it mean that we're bridging less? Ultimately, what is the impact of a blended execution environment? I think you spoke to a lot of how the blended execution environments impact the developer's experience. How would you say that it impacts the user's experience?
So yeah, it's a good question. I'll talk to just the typical user pre, I guess, chain abstraction and then post chain abstraction. So and clearly that's like, whatever, like it'll evolve over time. But an easy way to think about the value prop to users is that their experience doesn't have to change whether they're going to use an app across these different VM origins or whatever you want to call it. And I think that ends up being like a very kind of big unlock where you can, no matter what kind of pops up, it can just be deployed on Fluent. It could be a new SVM app, it could be new EVM app, and the developer experience is all the same. Now, the interesting part about blending, right? Like we're not trying to prescribe, and this kind of ties to the multi rollup thing. Like we're not trying to prescribe that our EVM compatible execution environment that supports, SVM, Wasm, and EVM apps is like the way to go. We're not trying to basically say like the only way to go. We're not trying to say like, oh, well, we're optimizing for EVM tooling and that's it. We would love to see somebody else optimize an experience around, I don't know, Move or SVM or whatever. If you have kind of like blended execution networks that, optimize for different things, for that user base, I feel like it ends up being like a much, much better experience than kind of the workaround solutions that still try to get the benefits of multiple apps in one place, but make the users bridge between what should just be one network or kind of switch wallets or stuff like that. No one wants to do that. No one's going to end up doing that. And it kind of like defeats the purpose of trying to support apps from those different ecosystems to begin with, because it's kind of disjoint. So that's where we look at the value of like blended today. If you look out into the kind of future of like how these things can evolve, how these execution environments could look with like fully blossom chain abstraction, I still don't think it like changes all that much for developers, because I feel like at the end of the day, we're trying to abstract everything away from users, but developers will end up caring where things are running, right? Every hop is extra, either like latency, every hop is extra risk. Like, so there are reasons. I see it on like a full trade-off space of like what matters to developers. And I don't actually see that changing post or whatever with a train abstracted world. That said, I do think that for the developer experience, you're right. And I'm sorry, the user experience, you're right. In that the user might not necessarily need to think about blended execution networks like at all. And that will just be like, hopefully the user is not aware of it at all. Like, hopefully this is all developer infrastructure. And, whether that ends up creating less like chains that you're deploying things to or not, I don't know. I mean, my bull case, like, I think there's going to be like thousands or millions of these things optimized in like pretty amazing, like incredible ways for like so many different use cases. So it's kind of hard for me to clearly, I don't know that one, but hopefully a user is blissfully unaware of this.
Yeah. I think most would be in an ideal state. So it's kind of tough to make speculative predictions of the future, but it's important to like think on it and kind of figure out. Like as a builder, I imagine, and I've done this throughout just various entrepreneurial things. You have to kind of take a bet on where you think the future is going and figure out how to align that, right? And align your product in that. And I think this has been an important step for what you guys are doing, with this blended execution. Kind of speaking onto that point, kind of to wrap up with the thought of going forward, you guys have now kind of changed a direction a bit, or at least narrowed in your focus. How has this affected your timeline previously, and kind of what is your updated timeline for the community?
Yep, totally. So, like I said, we had shipped a private DevNet, or first private DevNet, and then we are re-architected things a little bit, and now we actually just maybe last week or so we enabled the Wasm and EVM app support like in full. That is like working now. We're feeling good about it, so we'll start onboarding some more devs to the private DevNet over the next month, and then pretty soon after, we hope to ship a public DevNet to let more people in, and then a public test net maybe sometime in the fall. We're also we're also working on the SVM part of it. Now that's like a little bit behind since we started that more recently, but it's looking good so far. I'm not exactly sure when that would get like integrated into the L2 for people to start using, but we're running a bunch of tests with it now, so that'll lag a little bit behind. And yeah, so I would give it maybe like a month or so before we're opening things up to devs.
Awesome, man. Feeling bullish. Thank you for your time, and congrats on the repositioning and just the focus of your company to kind of just think about, okay, what does this ecosystem need and how can we provide that? And yeah, excited to do another podcast in 6 months or a little less and see where the developments have taken us. And yeah, again, thanks for your time.
Yeah, thank you guys. Always fun. And maybe we can jump back on. I'll probably I think we were talking about this offline. I'll bring on Dimitri and we can kind of do a proper technical dive. We're catching up on all that documentation right now, but starting next week, we're going to be sharing a lot more info. So I'm excited and happy to jam with you guys on that.
Sounds great. Looking forward to it.